In this example, we'll use the results of a separate thermal analysis to apply loads to this model. So I've got my solid model up. I'm going to bring up my shell model that contains the temperature results. And then we'll just tile the windows so we can see them both at the same time. And what we want to do is actually extract the data from this one and then apply it over on this model here. From the shell model, we'll actually create a mesh output data surface. Pretty much all you need to know is the title and then which vector the data is. And this is all in one vector with nodal temperatures. Say OK. Basically fills in this data surface. And I'm going to copy this simply to the clipboard. And now I need a couple node points in here so I can align this later on. I know that the two things are not correctly aligned, so I'm going to do list model node. Just list these two nodes, and we'll use them as an alignment vector later on. So let me grab this information. I'm just going to copy it to the clipboard, throw it in Notepad for when I need it later on. So let's bring that data surface over to here. We're going to copy it, go to the other one, paste. Now we just want to see what it looks like where it's at, so we're going to plot it. And as I already knew, it's not aligned, so I need to get it down there and aligned to this data. So what I'll do is there's a tool built into the data surfaces that says align. And I want to go from a vector that is X, Y, Z right there, 587. Hitting the tab key in between things with 5, 23.29. And then the Z value of that. So there's my initial vector, and it looks like it lines up on that mesh correctly. And then I just want to get it down to here. And what that'll do is just bring the data surface down to there. So now it's in the right place for the creation of loads. So we'll create model load nodal. And we'll select all the nodes on the solid because they're in that group. And again, we'll go 1.0. And the data surface this time will be that mapping data surface. And it will run and do the same type calculations. This time it actually has a mesh to back it up, not just a linear field or a bilinear field. It's actually projecting the nodes into that mesh and figuring out what output value is at that location and bringing it back and applying it as the nodal temperature. So we'll just let that finish. There we go. And I'll say cancel. Don't really want to create any more nodal loads. I'm going to shut down the thermal model. And then just double click that to bring it full size. And let's just take a look at that load distribution. Create an empty output set. And create some output from the temperature loading. We'll see how well that mapped. There's our data. Looking pretty good so far. And you see we get pretty much the same distribution we had in our other model. Looks great. Again, I've already run this in Nastran, so we'll just take a look at the results. So that's an overview of using Femap data surfaces.